So now let's introduce friction into our problems. Right? It's the same thing. We know that work done is force times distance. Now if there's a friction in it, right, then all that is there's a friction element times force times t. So that's all there is. Okay. All right, so let's solve problem 14-41. Use the work energy method to solve for the velocity of body A in the if the force P equals 100 pounds, moves block 40 feet. Okay. Right, so there's a little diagram, and I'm just going to draw the free body diagram for this. So there's a force P equals 100 pounds pulling it, and the body weighs 500 pounds. So obviously there's going to be a reaction. We'll call that Fn, and the motion is in this direction, so the friction is going to be the kinetic friction coefficient times Fn. Right, okay. So the way we set up this equation is pretty simple. So this force times the distance it moves. Let's write the information that's given. Weight is 500 pounds. Okay. Coefficient of friction is 0.3. P is of course 100 pounds. S, the distance it moves, is 40 feet. V is what we gotta find out. Okay. Alright, so P times the distance is equal to half mv squared plus the work done by friction, which is mu coefficient of friction times the reaction force times the distance that the body moves. We just need to fill this in. 100 times 40 equals half. Mass is what, 500. So 500 is the weight, so 32.2. Now this becomes mass. Velocity is what we gotta find out. V squared plus coefficient of friction is 3. Fn is, there's no other vertical force, right? So there's no other vertical force, so basically Fn is equal to 500. Those are the only two vertical forces. 500 times S is again 40. So when everything is calculated, V is equal to 16 feet per second.